Let us explore how artificial intelligence is revolutionizing the field of robotics and shaping the future of automation. AI-powered robots integrate three fundamental components: perception, decision-making, and control systems. These elements work together to enable robots to understand their environment, make intelligent decisions, and execute actions precisely. Each component leverages specific AI technologies like computer vision, machine learning algorithms, and advanced control systems to achieve autonomous operation. AI-powered perception systems enable robots to understand their environment through multiple sensors. Computer vision algorithms process visual data to detect objects, estimate distances, and track motion in real time, allowing robots to navigate and interact with their surroundings safely and efficiently. Here is an example of how computer vision can be used in robotics using open-source computer vision library, also known as CV2. We import the CV2 library in NumPy. NumPy is the fundamental package for numerical computation in Python. Then we define a function called processRobotVision, which takes frame as an argument. This function converts the colored frame to grayscale. After that, it detects objects and estimates the distances of those objects from the robot. Finally, it returns the objects and their distances. Robots use continuous analysis of sensor data and environmental conditions for immediate decision-making. They use dynamic adjustment of actions based on changing circumstances and new information. Robots also evaluate potential outcomes and safety considerations before executing actions. Finally, they use continuous improvement through machine learning from past decisions and outcomes. As shown in the diagram, based on the sensor input, robot analyzes the environment. If obstacle is detected, then it assesses the risk. If the risk is high, it stops and recalculates the path. If risk is low, it plans the path. If alternative path is available, it adjusts the route, else it waits for clearance. If there is no obstacle, then it continues the task. Robots use reinforcement learning, which enables them to learn optimal behavior through trial and error, maximizing cumulative rewards for successful task completion. For perception, they use deep neural networks to process visual data for object detection, pose estimation, and scene understanding. They also use predictive models to forecast system dynamics and anticipate required adjustments for smooth operation and control. Here is an example of reinforcement learning code using TensorFlow and Stable Baseline's 3 libraries. We first define the robot environment. Then we define the action space, which specifies the range of possible actions that the robot can take. Then we define the observation space, which specifies the range of possible observations that robot can observe. After that, we define a step function which executes the action and gets the feedback from the environment. It also calculates the reward. In AI-enhanced control systems, AI model optimizes the controller performance. The desired state is fed to the controller. Controller controls the robot actuators, which then act on the physical system. Sensors sense the data from physical system and sends it to the state estimator. State estimator provides the feedback to the controller. Advanced proportional integral derivative control, also known as PID, control with AI-tuned gains for optimal performance across different scenarios. Kalman filtering enhanced with machine learning is used for improved state estimation accuracy. Smart robots are used in manufacturing and assembly, which utilize computer vision and deep learning for precise assembly, quality control, and adaptive manufacturing processes in smart factories. In healthcare and surgery, AI-powered surgical robots provide enhanced precision and real-time guidance for minimally invasive procedures and complex operations. In exploration and research, autonomous robots are equipped with advanced sensors and AI algorithms for exploring hazardous environments, deep oceans, and outer space. In agriculture and farming, smart agricultural robots use machine learning and computer vision for precision farming, crop monitoring, and automated harvesting. Complex AI models require significant computational resources for real-time decision-making and control. The solution to this problem is implementation of edge computing and model optimization techniques for faster processing and reduced latency. Another challenge is difficulty in adapting to new situations and environments not covered in training data. The solution is integration of transfer learning and continuous learning systems for improved adaptability. Ensuring consistent performance and safety in critical operations and human interaction is another challenge. The solution is implementation of robust validation systems and fail-safe mechanisms with continuous monitoring. Natural interaction and seamless collaboration between humans and robots is also a challenge. The solution is development of intuitive interfaces and context-aware systems for enhanced human-robot interaction. In the future, there will be advanced collective behavior through distributed AI systems, enabling multiple robots to work together seamlessly. This is called swarm robotics. Also, there will be robots with the capability to continuously learn and evolve their AI models through real-world experiences. This is called self-evolving AI. Another trend is next-generation robots incorporating AI systems inspired by biological neural networks and natural behaviors. This is called bio-inspired robotics. AI and robotics continue to evolve together, creating more intelligent, adaptable, and efficient autonomous systems. Enhanced human-robot interaction leads to more natural and intuitive collaboration across various industries. There will be transformative effects on healthcare, manufacturing, exploration, and everyday life through advanced AI-powered robotics. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.